Hello everybody, my name is Alberto and I'm currently developing a turn-based strategy game using the Unity engine. In today's devlog, I wanted to show you how I've implemented the networking or multiplayer for our game. And I'm going to make this a bit live. I'm going to just start a new game and drive you through the game and move back and forth to the code so I can explain you how these things are implemented under the hood. So let's first start our multiplayer game. Here I have two editors, as you can see, with the game running. And what I'm going to try to do is to connect one to the other. What I mean is one of them is going to be the host, which is going to be the server and a client at the same time. And the other one is going to try to connect to the server. For that, I need to input my public IP and press connect. So you can see that the moment we've connected to the server, this has received the connection, assigned to this client a new ID, which you can see here in the log, which is the ID number 2, and now we are ready to start our match. So let's go. Let's move forward and start the match. Okay, the moment we start, you can see that we get in both editors, we started the game. But on the right side, we have a different view. We can select units, so we can actually spawn units. This is because this is player number 0, and this is the turn of player number 0. And this is now waiting for the other player to perform the options, and it can do not much more than look around in the map. So we're gonna spawn some units, and then we're gonna talk about or look at the code, how these things are implemented. So I'm adding units here, and you can see that these units were already appearing on the other client, and now we have already moved to the next player turn, which is player 1 in this case, and here we can actually select units and spawn them on the map. So let's now take a break and see how all these things can happen, what is happening under the hood. If we look a bit on the log here, we can see that we are sending several messages. Okay, so we send a message called end to network message, turn end, and units spawned. These kind of messages have been traveling across the network. So let's take a look. What are these messages? Let's then take a look to where is the remote player and the actual player that is handling the turn in the code. We have different states, and the whole game is made of different state machines. For the remote player, we have as little states as possible, and we want it to follow as much of the client states. Why? Because we want to always keep the same state of the game and synchronize as minimum as possible sending as minimum as possible messages to produce this behavior. So we have this remote human units spawning a state. This is the state in which now the remote player was, and this player, as you can see here, is doing nothing. It's just handling the hex focus change event, which this was basically this color that's changing as I'm moving here, but it's doing nothing else. It's waiting actually for the other to do something. And the player that actually has the turn does much more other things. It's actually handling many other things, and one of them is to wait for clicking on the hex. When you click on the hex after certain conditions, you will create a spawn units command, and you will execute this command. And here is where it comes a funny part. If we are handling a network match, then we are going to send to the server a message. In this message, we are going to say, hey, we are spawning units, and these here are the units we are spawning, which in this case is very simple. It's the same unit and only an amount. But this is, you're going to do that. You're going to send this message. And how this message is handled? Well, this goes to the server, and the server broadcasts this to all the clients. And we have a system here, which is called remote player system, and this is the one who is actually listening to the network. When we enable this system, we subscribe to all kind of different messages. And here we have the units spawn message. What happened when you receive this message? Well, the first thing you do is to check that if you are the local or not. If you're the local client, in this case, you don't want to handle this message. You actually send this message to the server. You don't want to do anything. You already spawn the units. Now, if you are the remote player, then you really want to do something. And here is where it comes. The unpacking of the message, which this is something I have to improve. We don't want to do reflection here for getting the message, but this is the message actually. Let's take a quick look. The message has like a signature, and it's just telling you which player, where, and what is spawning here. And this is a network message which implements serializing and deserializing methods to be able to pack them in a message that can be sent to the server and then unpack them the moment we receive it as a client. And that's simple as this. And it's good to have the data also as a network data, serializable data, which also implements this and makes your life easier when you're unpacking messages. So we've received this message, and what we do is we are not directly spawning the units. Why? Because we have to deal with latency and problems with the network. So what we are going to do is to have a system which actually handles the remote commands, let's say it. And we enqueue this command, and we say, hey, we received this spawn units message, so enqueue this command, and we're gonna perform this whenever is the turn for this command to be performed, because maybe we receive several messages while we are still handling one of them, and we don't want to miss anything. We can be behind but not lose any information. That's the whole idea of enqueuing here. And that is how it actually happens. And in this case, this command, what it's going to do is to exactly the same, spawn the units. And we will have different things happening here. So let's move on to the match. Let's then finish spawning units here. We're gonna get this, this, and this, and we are done. Now what happened? Well, we just moved to the next phase, and now it's the turn for this player to do something. I believe, yeah, it's turn of player 0. So this one I still can look around and see things on the map. We've implemented many more UI feedback for the players, which was very important, was very little, and was needed to continue to have more information of what's happening in the map. So we can see here different unit group for all the players and some visual indications of what is the state of these units. So let's continue. Let's say that I want to move these units somewhere here, and this is an interesting part of the networking. So if I say move here, you can see that this actually synchronized pretty fast. But one of the things you can notice here is that the units are placed in different than here. Why? Because this is not relevant for the game. I don't care on that. And this is a random thing that happens in the game. So I'm not synchronizing this. The only thing I'm synchronizing here is that you have this unit selected and you have to move here. How this actually happened here? Okay, let's take a look. Quick look here. So we have one message for units group selected. This is a very simple message. The moment I click and select a unit, I'm telling to the clients, hey, I've selected a unit group. And it's as simple as saying, hey, perform this action, which is this system has to select these units. Why I do this? Because this is what the client is also doing. The client is performing this action, and the client, the system in the client, in the local player that is now playing, has selected this unit. So I want all the clients to do the same, to be in the same state. So we are now with the group selected. And the next thing is I'm saying is, say, move somewhere, no? Move unit group. So we already have selected a group. This is the one is going to move. So what we are doing here is enqueuing this action, and we are first of all getting the path to the hex that they are moving, and we are then, this is important, changing to the units moving state. This is important. Why? Because now we are going away of the remote state. We were in this state, remote human action state. This is the state where we are now. And again, we only handle the focus change event. So we only handle the visuals on the map. But now we are moving somewhere else. So we are actually going to this units moving state. We are going to this state. Why I do it this way? Well, the whole reason I'm doing it this way is because there are many things happening here, and I want to be exactly the same in all clients. So I want them to follow the same process. And that makes it also much more easy. I don't have to synchronize the many things. Everything is going to happen in the clients. So it's going to create the move commands. It's going to create a composite command which has all the move commands, and it's going to perform all these commands. Okay, and what is the main difference here? Well, when the unit's movement is completed, these things happen here. This is all fine. And at the end, we go back to the selection state. And now here, everything. This is the only point in the code which has to be handled. Why? Because if we were a remote player, we don't want to go back to the human action state. Otherwise, we would have now all clients able to move units in the map. No, then what you want to do is to go back to the remote human action. And we also, this part, we just need to execute the next command because we are finishing by ourselves this command of moving. We cannot, it was difficult to make it itself that this is recognized. So you manually say execute the next command if there is any next command. But this is the only thing. So that means that in all the state machines, at the endpoints of the state machine, so when the movement is finished and you go back to the action, so these endpoints, these leaf parts of the state machine needs to check if it's a remote or the local, and then just say, okay, go to the starting point of the remote or starting point of the local. And that's the only thing we have to deal with in this part. And for the rest, everything is fine. When I end the turn also, well, we can now start doing things. We can split units and this will work. We can recruit units here. Let's say range units. This should also work. And as you can see here in the one that is working, we added also some visuals. It becomes a bit dark. That means that this unit groups has no more actions. They cannot do anything else. And these ones, they still can do something, so you can select them. And if I now try to end the turn, we have something here like, hey, do you still want to cancel or not? So you can move or not. This one is still waiting. So we can end the turn and then we go back to this one. And then this one can move and perform the actions. So this is mainly it, and we can continue forward. And as you can see, it's just about sending the minimum necessary messages and just let the code go through the shared code and do exactly the same things in both sides, then you won't have problems. So if I go here, the other part that was also a bit difficult to handle was the attack and the combat, because there is a lot of randomness here. And you want to synchronize things and perform animations as fast as possible. So if I say attack here, now it actually works pretty well. It goes quite fast and it happens exactly the same. Why? Because now I'm actually performing all the calculations before doing anything, and I know the result, and then that's what I'm going to send as a message. So here you can see that if I do human, if I go, I think it's the human units action state, combat decision, right? Human combat decision one. So we will see what is actually happening here. We go to the units combat. Yeah, there are pretty a lot of states. Unit combat state. Because this is a shared state, that's why it's not human or AI. There's AI also in play in this game. So here we perform the attack command, and we will going to do that. And as you can see, we have something already, combat result processed event. This is something that happens before performing anything. And when this happens, I'm already going to send information. And I'm sending things like, okay, this is the attacker, this is the defender, this is where it's happening, this is the result for the attacker, and this is the result for the defender. So I know everything. So then the other can handle this with all this information. And again, we want to handle this following the same attack command, following the same process here. And that's what makes it a bit difficult, because then when I'm here, I have to check something, and it's somewhere I'm storing this data. Hey, we have a system for combat, and there I'm saying this is the result of this combat. And then if I come here and I say, hey, is there a result of this combat? If there is no result, this means that this was the local client and it's starting the combat. But if it's a remote player, through the method, we already set this result. So there will be a result here. And this is what makes the difference. Or you process the combat, or you get the combat result. So this is the network, the remote player, this is the local player. And the rest is the same. Handle animations and all the stuff, the units loss drawing, everything else is the same. So I hope this was helpful. I don't want to make this super long. I think this is long enough. And yeah, We are now implementing also that the AI can also be networked. Now it's only players and can be up to 4 played. We've tested this with several players, and we are of course adding more and more features. But this was an important one to do now. Otherwise, it gets very complicated if you do it later. And so far, it works pretty well. There are some bugs, some errors, but things are synchronizing fine. It's easy to implement more things and taking care of the network part. You almost don't have to do anything, and that's the whole idea. Just send as minimum as messages as possible, and then handle everything through the shared code. That's the relevant thing. And yeah, so thanks for watching, and see you next time.